Leetcode 91 decode ways. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. Okay, so we have a string, that's our only input, and it has some elements inside which should mean just numbers, and then those numbers can be mapped to letters. And here is the mapping. 1 maps to A, 2 maps to B, which is already important thing that we have to notice at the very beginning is that 0 is not a valid encoding. Yes, there is no letter that maps to 0. And the second thing, if we go down here, we notice that we have double-digit numbers which are valid encoding. So for example, 25 maps to Y and 26 maps to Z. So it starts somewhere in the middle with 10, and the last one which is valid is 26. So from 10 to 26, that's the range which is valid for double-digit numbers, and 27 already is not a valid, 30 is not a valid, and so on. And so we have to check for double digits if we are within this range. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. So if we have 2 and 5 next to each other, then we can either decode it as a single 2 and a single 5, or put them together as 25, which is also valid, and that would be Y. Yes, and here is first bigger example, 1, 1, 1, 3 times 1, 0, 6, which can be decoded into AAJF, which is 1 as a single digit, 1 as a single digit, then 10, then 6, or 11, 10, and 6, but you cannot do 1, 11, and 0, 6, since 0, 6 is not a valid code. And because it has a leading 0, and it would be like a double digit, which is not in the range from 10 to 6, 10 to 26. Yes, so let's just copy that and think about it for a second. So we are on the same page. Yeah? So for example, here we have 1. And here we have, let's say, 1. Here we have 10, and here we have 6. So that's one valid way to decode that. That's what we are 1, and here is 10. Take 2 digits here, and here is 6. Yeah, and that's a valid way. We didn't violate any rules. But if we try to do something different, and let's copy those as well. And if we try to do something different, like here, let's make it black again. Let's make it black. And try to use 0, 6 as our double digit number, then that's not allowed because we violated one rule. So let's just write everything down here. Bigger as the others, and that is not allowed because here we violated one rule. So what are those rules? Let's write them down. Single digit cannot be 0. And then the second rule, double digit between 10 and 26. Let's put it down here. Like that. And maybe we can even add a frame so we don't forget that. Those are our only 2 rules, which we already see on that simple example. So let's read what else we have to do. Note, there may be strings that are impossible to decode. So what if that leading 0 happens to be the very first char that we have in our string? In that case, we cannot decode that that string, because if we take If we try to take it as a single digit, then 0 doesn't map to anything. And if we try to take it as a double digit, then 0 first and something like whatever digit is after that doesn't map also for sure to our range between 10 and 26. So in that case, both rules would be violated and we cannot decode such a string. And here is our task. Given a string S containing only digit, so they already guarantee we don't have to add any checks inside our algorithm. If we even have digits, for sure there will be only digits. We have to return the number of ways to decode it. So we don't have to decode the string ourselves. We just have to count the number of valid ways. And if the entire string cannot be decoded, then return 0. The test cases are generated so that the answer fits in a 32-bit integer. So, for example, in certain languages, you can specify the type of your variable. We will not do it since we code in Python, but if you specify like certain smaller integer, there are like many types of integer, and certain smaller ones can take less memory than the others which are bigger, but those bigger can fit into a bigger integer. And so if you code in such a language, then you can take advantage of that information, but we will disregard it. And here is a first example. So we already had a couple examples before, but first example, which is like separate to the description itself. We have 12 as our string, and there are 2 ways to decode it. So of course we can take 1 and 2, both separate, or we can put 1 and 2 together and get 12, which is also valid. And the second example is more interesting because it's a bit longer, so we can already think about an algorithm that would solve that. And we will take a look into it in a detail in a second, but the last one is just a reminder that if you have a leading 0, then it's invalid. Yep. So let's take a look into the second example, and let's try to come up with some algorithm that will take into consideration all the things that we have mentioned so far. We can move our rules of the game. Okay. That's a bit like this. It was a bit bigger than I expected. Let's put it here. Let's scroll down so we have some space, and we will need, of course, counters. Yes, whenever there's a count that they ask us to do, then we have to have a counter. Maybe let's not call it a counter. We have to have some good names. So there are 2 options always, yeah, single or double digits. So we have to accumulate the ways that we counted so far. So for single digits, we will use 1 back, and we can start with 0 or with 1. We will discuss it in a second. And for double digits, we will use 2 back, yeah. If you have a better name, you can also choose a better name. And here is the thing about this initialization. So we've already mentioned that there is that one big edge case. If here at the very beginning we can already say that something is invalid, when initial check that we can do is it 0 or is first char? And that's the very first check that we can make, separate to the rest of algorithm. And if so, if yes, if the answer is yes, then return 0 if yes. And if not, then we know that there's at least 1 valid way. Yeah, so we have already counted 1 valid way. So if we do this check separate to the main loop, then we can initialize our counters with 1s. And we've already checked the first, and we can proceed with our checks. And here is the main algorithm. So the algorithm will look like this. Check if single digit valid. Check if double digit valid. And slide further. Now that's more or less it. So we can put it here, maybe on the side. And we can even expand it to write down what happens if it's a valid. Yeah, so if it's a valid, then we increment our counter by all the possible ways that we counted so far for single digits. And if double digit is valid, then we do the same. Now, in the end, we slide. So what we do, one back first, maybe two back gets what was inside one back, and one back gets what was inside the counter. And the counter is initialized every time to 0. And that's the loop that we will have to do. And that's our whole algorithm. So how does it work here? For the first iteration, let's write it down. Iteration 1. What is our single digit? It's 2. And what is our double digit? It's 22. That's the double digit. So does it violate any rule? No. So we can increase. Let's copy the counter. First is 0. And here we can increase the counter by 1 back, which makes the counter 1. And here 22 doesn't violate any of that rule, so we can increase it by the ways that we counted so far for double digits. So the counter will be, so at this point was 0, at this point is 1, this point is 2. Yeah, and at the end we do the slide. So 1 back becomes 2, and 2 back stays as 1, since this was the previous one for the 1. So we do that slide. And in the second iteration, we move here. Our single digit will be 6, and double digit will be 26. Yeah. So let's slide a little bit down. We start counter with 0. As single digit is 6, which increases our counter by 1 back. 1 back is at this point 2. So here we will have not 1, but 2. And here we will have not 2, but 3. So and in the end we slide, so this one will be 3, this one, and so forth. Yeah, we have a longer string, we will just continue. So here is our answer. That's the number that we have to return at the end. Now we have to convert it to code, which we already almost did since we fused variable names. But the initial check let me write it down. So let's start with initial check. Then we can proceed with the loop, the main loop. And at the end, we return the result. So now we'll just convert to code the thing that we have written previously. So if the string is empty or the first character is equal to 0, then we can already return 0. If not, then we can initialize our counters. So 2 back is equal to 1 and 1 back is equal to 1. And here is the main loop. So for index in range from 1 to length of string plus 1. We have to initialize the counter to 0. I'll take a single digit. Will be simply as on the position of index, and double digit will be as on index -1 till index +1. And with colon like that. Yeah, so those are our digits that we check, and we can convert them to ints since here they are still strings. And what is the check for a single digit? If single digit not equal to 0, then we increase the counter by the ways that we counted so far with 1 back. And for the double digit, if double is greater or equal to 10 and less than or equal to 26, that was our range. Then we can increase the counter, and by the end we have to slide. So 2 back becomes what was before 1 back, and 1 back gets what was in the counter. And that's more or less it. We can also exit early if 1 back is equal to 0 by this point. And the result is in the 1 back counter, since it has the last value of the counter itself. I guess that's it. So just 2 rules, 2 counters, and initial check. That's more or less it. Let's try it out. We have index out of range. $13. Here we don't have to go to +1. That's already enough if we go to length of string. And the issue is here I reversed the logic. So yeah, always double check what you write. So it's very easy to get lost in such things. And now we have covered the first 3 cases. So let's try everything else. So with the initial coding, it's easy to get some small details wrong. That's why it's always prefer to first check the first 3 cases or 2 cases, however they prepared, and then when you know that your algorithm is more or less correct, then you can proceed with all the test cases, and we have beaten everyone, beats 100% of the people when it comes to time complexity, and when it comes to the memory, 70%, which probably we could get rid of something here or some conversion, something like that, but we don't have to do it now. So I wanted more or less just to discuss the algorithm itself, and of course there are more tricks that you can use and you can share also in the comments.